Hi, this is David. We are back and we are again talking about Azure Data Explorer, sometimes known as ADX. I've got a cluster out here. I created this in an earlier video. It's called GCast ADX. In that cluster, I have a database. Down here, you can see it called GCast. If you watch the previous videos, you know that I can go to dataexplorer.azure.com and start writing queries against that database and creating tables and creating other objects as well. I'm going to work with a table that I used in a previous video, but I'll recreate it here. I'm going to draw this customers table by executing .drop table customers, and then I'll create it again right there, and then I'll ingest a bunch of data into it. Not a whole lot, maybe 10 rows or so. But you can see there's a full name, last order date, year-to-date sales, what I'm mostly concerned about, and postal code. Now, I can query this. I can write a query something like this. That'll return the count and the minimum year-to-date sales and the maximum year-to-date sales. I'll give names to each of those columns and the average sales for each postal code in the table. Here's the table itself. Right there. And although there are 10 rows in here, there are only 6 different postal codes, and you see the number of each and the min and the max and average sales for each one of those postal codes. And this is fine. This works. You can always write that query. But if you're running this query over and over again, or maybe starting with that and then filtering it beyond that or sorting it beyond that, it might make sense to create a materialized view. Materialized views are designed to pre-aggregate ADX data. They store a view with the data that has already been summarized. And so I can take this query right here, put it into a materialized view, and then just query that materialized view, and then I'll have to go to the calculations of, the count and the min and the max and the average. That'll be done for me in advance. I take a little bit of a performance hit on every insert because it'll have to do that calculation again, but I will save time when I run my queries. So this is really designed for queries that you're going to run multiple times, especially ones that take a long time. With only 10 rows, this wouldn't take a long time, but imagine if you had millions of rows, hundreds of millions of rows, then that would take a long time. All right, the syntax for this, and I can find it, I'll just search for ADX.create materialized view. That should take me right to the docs here. And there's the syntax, create. I always do it asynchronously, materialized view, and then some properties here. You can see some of the properties that are available to you. And then the name of the materialized view, the table you're going to query, and the actual query itself. All right. Here's the properties down here. This is an important one, backfill. If you set backfill equals false, which is the default, it will only start summarizing data going forward. Any data that was in that table already does not get summarized. So generally, I will set backfill equals true because I want to summarize all the data in the table. But be aware that if I have a very large table that has a lot of calculations, it might take a long time to do that backfill. Other important ones here are a doc string, and this is really nice if you want to have a description. So add some metadata so people know what it is. I mean, you can certainly give it a descriptive name, but this allows you a lot more information. And if you want to organize, if you have a lot of materialized views, you can organize them into folders. So let's go ahead and show an example of a materialized view that runs this query right here. I'm going to .create async materialized view with backfill equals true and docstring equals this. I won't create a separate folder for this one. The name of the view will be my materialized view. It's on my customers table, and the query is just the one that I ran above. That's my summary. It has to be an aggregation query. If I don't have this aggregation to summarize by something, it'll throw an exception. That's materialized views are specifically for aggregations. So I'll run this statement here. right there. Now the Materialized View is available, and I can query it simply with the same way that I query table. Right here, and run that, and there it is. There's my query right here. I can also order by the postal code. Spell it right. Code. It acts just like it was a table on here. I can filter it. I can even summarize this if I want to. I can change that if I decide this isn't what I want. I have the alter materialized view syntax. And let's say, for example, I didn't care about the min sales. I only cared about the count and the max and the average. I could alter this with the .alter materialized view, and syntax is almost identical to the create materialized view. Here I've got a query, and it's just the same one I had before, except it omits the min calculation. So now when I run this materialized view query, then I have a much one less column. And finally, if I'm done with this, I've decided, you can see it over here. If I refresh this right here, you can actually see it in this. There it is. But if I'm tired of it, I made a mistake, I want to get rid of it, there is a drop materialized view. I give it the name of the view right here, and this will remove it from your database. So now if I try to query it, I'll get an error because that materialized view no longer exists. That's materialized view in a nutshell. Get a little bit of performance hit every time you insert a row because that's to do that aggregation. But if you're using that aggregation a lot, you'll save a lot of time when you query this rather than the base table. This is David. Thank you for watching.